Hello everyone, welcome to our YouTube channel Engineers World. Here in our channel we are focusing for the exams like GATE, ESE, IPATE, SSC, JEE. So in the previous lecture in surveying I was dealing with accuracy and errors. So we will be continuing that topic today. So our today's topic is errors in the computed quantities. Errors in the computed quantities. See, the measured quantities like length and angles are used for computing differences in distances, elevations, areas, and volumes. Naturally, the errors in measured quantities will propagate into computed values. So evaluations of errors in the computed quantities as functions of the error in the measurements is called error propagation. Now, I'll directly show you some standard results which are as see, in case of addition, see, these are results, right? Here are results. Here is maximum error, and here is probable error. So in case of addition, I'll denote addition by plus. If our quantity is the sum of two quantities or measurements, then the maximum error will also be the sum of the errors of that quantities. And the probable error, the formula will be under root ex square plus ey square. Similarly, for subtraction, I'll denote by minus. If the equation is s is equal to x minus y, where x and y are two different quantities or measurements, then the maximum error will be same as that in addition. And probable error will also be same. Now coming to multiplication. So the maximum error will be x. So in this case the formula for maximum error will be x dou y plus y dou x. See here, dou x and dou y are the errors in the quantities x and y respectively. And the probable error will be different. The formula will be s under root ex by x whole square plus ey by y whole square. Now in case of division, s is equal to x by y. The formula will be different. Dou x by y plus x dou y by y square. And this will be same. I can write it as same. So this is an important table and these are the standard results. You just need to remember these values in case of addition, subtraction, multiplication as well as division. So these are the formulas for maximum errors as well as probable error. Now we will solve a numerical based on this. See, numerical says if we have given a quantity S as the ratio of two quantities 23.9 upon 8.34, and he has given error in x dou x as plus minus 0.05 and error in y dou y as plus minus 0.005. See, we can these are maximum errors. We can easily calculate these errors by using the digits after decimal places, as I explained you in the previous lecture. So here we can see if this is x and this is y. So this is an equation, this is a division form, that is s is equal to x by y. So for the value of maximum error, we can calculate dou s is equal to, the formula used will be plus minus dou x by y plus x times dou y by y square. So on substituting the values, we get plus minus, see, dou x is 0.05 upon y is 8.34 plus, or x is 23.9 into dou y is 0.005 upon y square, or y is 8.34 square. So on solving, we get dou s is equal to plus minus 0.0077. So this was an example of errors in the computed quantities by making use of division formula. So we'll move on to the next type of numerical. See, the next numerical which I'm going to solve, this numerical came in ESE 2016. So the question simply says the side of a square land was measured as 150 meter and is in error by 0.05 meter. So he is saying what is the corresponding error in the computed area of the land. The options are A 5 meter square, B 10 meter square, C is 15 meter square, and D is 20 meter square. See, it's a very easy numerical. What we'll do, we'll simply use the formula of area. We know that the area of square is side square. If I denote the area of square with A and side of square with S, then the formula of area will be side square. Now, if I differentiate both sides partially, we get this. Now, what he's asking what is the corresponding error in the computed area. So this thing he's asking. So we have got the formula, we just have to put the values and get the answer. So our side is 150 meter and dou s is the error in side. that is given as 0.05. So on substituting these values, we get 15. So our error in area is 15 meters square. So the option C is correct. So now you can easily solve numericals on the errors based on errors in the computed quantities. Hope you have understood all this. Now moving on to the next topic, that is concept of weights. So the question arises, what do I mean by weight in terms of quantities or in terms of error? See, weight, it is a numerical value assigned to measurement, any measurement, on the basis of degree of precision adopted, which represents the importance of reading. And numerically, or you can say the relation between weight and error is inverse. So weight is inversely proportional to error. Now we will move on to the laws of weights. See, if any measurement x1 is taken with weight w1 and another measurement x2 is taken with weight w2 and k is any constant, then we can apply a lot of operations like addition, subtraction, multiplication by a constant, division by a constant, or addition or subtraction with a constant. If I use the operation here, I will write the operations. If my operation is, first is addition, here's my operation, that is addition, and here is the result. So for two quantities, addition will be simply x1 plus x2. So weight of result, now remember this, weight of result will be 1 upon 1 by w1 plus 1 upon w2. Similarly, in case of subtraction, the result is x1 minus x2, or you can say x2 minus x1. But the result is still same as, but the result in terms of weight is same as this 1 upon 1 by w1 plus 1 upon w2. Now second is multiplication by a constant. I'll write it as multiplication by a constant, let k. So result will be k into x1. So remember, if any quantity is multiplied by a constant k, then the weight of the result is divided by the square of the constant. So this was all about multiplication. Now next operation is division by constant. I'll write it as divide by constant k. So a result will be that quantity divided by constant. Now the result, weight of the result will be weight of that corresponding to that quantity multiplied with the square of constant. So these are actually the laws of weight which I am teaching you. So next is addition or subtraction with constant k, or you can say x1 plus k or x1 minus k. So in this condition, the weight of result will be simply w1. So there will be no effect of addition or subtraction of constant on the weight of result. So hope you have remembered all these laws. So this was all about laws of weights. Now we'll solve a previous year numerical which said this numerical came in GATE 2015. So the numerical says, in a survey work three different angles X, Y, Z were observed with weights WX, WY, WZ respectively. Then he is asking the weight of the sum of angles X, Y and Z is given by the expression. Options are 1 upon 1 by WX plus 1 by WY plus 1 by WZ. Another option is simply 1 upon WX plus 1 upon WY plus 1 upon WZ. And C is WX plus WY plus WZ. And here D is WX square plus WY square plus WZ square. See, as I recently told you that in case of first law of weight, we'll use the first law of weight, that is in case of addition or subtraction. So our answer goes with option A. So option A is correct. Now this was a GATE numerical. Now coming to the last numerical of today's lecture, that came in ESE 2016. So the numerical says, numerical is not a numerical, it's a question, you can say theory question. Question says, which of the following statements are rightly associated with the laws of weights in the theory of errors? The first option says, if an equation is multiplied by its own weight, then the weight of the resulting equation is equal to the reciprocal of the weight of the original equation. Second option says the weight of the algebraic sum of two or more quantities is equal to the reciprocal of the sum of individual weights. Third option is, if the quantity of a given weight is multiplied with a factor, then the weight of the resultant quantity is obtained by dividing the original weight by the square root of that factor. And fourth option is, if the quantity of a given weight is divided by a factor, then the weight of the resulting quantity is obtained by multiplying the original weight by the square of that factor. The options are 2 and 3. A part is 2 and 3, B is 2 and 4, C is 1 and 4, and D is 1 and 3. As we can clearly see that the option 1 and 4 are correct. That says if an equation is multiplied by its own weight, then the weight of the resulting equation is equal to the reciprocal of weight of the original equation. And if the quantity of a given weight is divided by a factor, then the weight of the resulting quantity is obtained by multiplying the original weight by the square of the factor. So that was all for today's lecture, and with this lecture the chapter of accuracy and errors has come to an end. From the next lecture we'll start with linear measurement. So that was all for today's lecture. Don't forget to like and subscribe the channel.